Alright guys, so we're going to go through the test one question at a time. If you're using a calculator, make sure that you're in degrees. If you're using your cell phone's calculator, if you turn it sideways on the iPhones, it turns into a scientific calculator, which gives you the option of sine, cosine, and tangent. But I believe you would have to input the number first, like whatever you're going to put inside the parentheses, and then type in cosine, or it hit cosine. I'll show you what I mean in a bit. First of all, if we're going to round to the 10,000s, okay, so I have here's my decimal, here's my number, let's say 0 or 10. 10,000s, well, here we have tenths, we have our hundreds, we have our thousands, and here is a number we want to round, which is our 10,000s. So in order for us to round to that number, first we have to look at the 5th decimal number. If it's 5 or higher, we round up. If it's 5 or less, we round down. Or it stays as where it's at. So let's take a look at the first one. So the first one, we have cosine of 38. So on an iPhone, I believe you would put 38 first and then hit cosine. On a normal calculator, depending on what you're using, you'll put cosine of 38, hit enter, make sure you're in degrees, and we get 0.7880. Now here, that 0 at the end is not really making a difference, but we'll just leave it. For B, we have sine of 67, so that's exactly what we put in the calculator, and we get 0.9205. And same for tan. Tan of 46, when we put in the calculator, we get 1.0355. And that was pretty much it. Number one, just make sure you're in degrees, and can you put in a calculator. Moving on to number two. Now, for this one, remember, now x is inside my function, so somehow I got to get rid of this tan. And so the equation that I'm going to use the inverse. And so I'm actually going to work it out one time for you guys up here. And so what we have is tan of x equals 15 over 23. And what's really happening here is when you use tan inverse, okay, you have to do what you did on one side, you got to do it to both sides. So that's where tan inverse on the right side comes. Now on the left side, because tan inverse cancels a tan, these two equations, the tan and your tan inverse, are going to cancel each other, and we're left with x. On the right side, we're going to put tan inverse of 15 over 23 into the calculator, and we're going to get our answer. And so where it says the equation here, that's what we're going to put. That's what we're going to write. So we have x equals tan inverse of 15 over 23. And so when we put that in the calculator, make sure you round to the nearest degree. So when we round to the nearest degree, tan inverse of 15 over 23 gives us a angle measurement of 33 degrees. For letter B, it's more or less the same thing. The only difference is, instead of using tan, now we're going to use sine inverse. So my equation would be x equals sine inverse of 12 over 55. So that's what I would put in the calculator, and the answer that I get for x would be 13 degrees. And we're going to repeat one more time, but this time with cosine inverse. So here we get x equals cosine inverse of 26 over 33. Put that in the calculator, and we get an answer of 38 degrees. All right, moving on to number 3. So it says use this triangle, and it wants us to write the ratio. In other words, it wants us to write what tan of B is equal to cosine of A, sine of B. And so remember, the very first thing we have to do is label this triangle according to your angle of reference. So one thing that's never going to change is what's across your 90 degrees. That's always going to be your hypotenuse. What is changing is your opposite side and your adjacent side, depending on what you use your angle of reference. So for the first one, or for 3a, or letter A, it says tan of B. That means if B is my angle of reference, across my angle of reference is I have my opposite side, and next to it I have my adjacent side. And so one thing we have to remember is tan is always going to be opposite over adjacent. So here my ratio, or my answer, is going to be opposite, which is 15, over adjacent, which is 8. And so I'm going to skip to C because I already have my diagram labeled to my angle of reference being B. And so nothing's changed here. The only difference is now we're using sine. Sine is always going to be opposite over hypotenuse. So my opposite side is still 15. The hypotenuse is 17. So that's my equation. Now I'm going to leave it labeled, but this time I'm going to use blue. And so I'm going to write it over just so that you guys can see it, but how it's changing. So if I'm going to use A as my angle of reference, okay, so here's my new angle of reference. We're color coding this. So if A is my angle of reference, across my angle of reference is no longer the adjacent side, but it's now the opposite side. And next to it is no longer the opposite side, but now it's the adjacent side. And cosine, and back up, hypotenuse does not change because it's still always across your 90-degree angle. So cosine is adjacent over hypotenuse. So here I'm going to have 15 over 17. And in your other problems, if you can simplify, simplify. And here, we can't simplify any of these, so they're going to stay as is. So moving on, number 4, it says write the angle of elevation and angle of depression. So angle of elevation and angle of depression, remember, they both always start horizontally and then either up or down. And so angle of depression is going to be here, okay? And what it's asking us to do is outline this angle. In other words, what are the 3 points, what are the 3 vertices, what are the 3 coordinates that create this angle? So in this case, it starts over at B here, and it goes towards A, and it ends at D. So my angle of depression, it's depression because he's looking down, starting horizontally and looking down. So my angle of depression is going to be angle BAD. And the same thing but this time for angle of elevation. Angle of elevation is going to be this angle here because you start looking horizontally and you look up. So my angle of elevation is here, where you start at either A, go towards D, and at C, or start at C, goes towards D, and at A. So my angle of elevation is angle CDA. For these next problems, it says round to the nearest tenth. So tenth, that would be 1 decimal place. And so if I'm going to do 1 decimal place, so here's my decimal, here's 1/10th place, I would have to look at this second number to determine whether I move this one up or I round down, or it stays at where it's at, sorry. So let's take a look at the number 5. It says for number 5, we have, the first thing I would do is label your diagram. So here they're giving me an angle of reference. And so we start across your angle of reference is always your opposite side. Here's my 90 degrees, which means this is my hypotenuse. And really, if I wanted to label the other side, that's adjacent. But that's not really important, because what is important is I have information for the hypotenuse, and I need, or I want, information for the opposite side. And so the only function that has both opposite and hypotenuse in it is my sine function. And so that's what I would use. So I would have sine of your angle of reference, which was 55, is equal to opposite side, which is x, over hypotenuse, which is 15. Now remember, because x is in the numerator, The only thing we have to do to solve for x is we're going to take this 15 here and bring it to the front. And so in my calculator, my equation would look like x equals 15 times sine of 55. And so that's what I'm going to put in the calculator. And so when I put that in the calculator, I get an answer of 12.3. So moving on to number 6. So once again, we're going to approach it the same way. The very first thing we do is identify what they're giving us. In this case, they're giving us an angle of reference and they're labeling it x. Across your angle of reference is what we call the opposite side. Next to it is we have our adjacent, and across 90 is always going to be the hypotenuse. The second step is identify what sides do you have information for and what sides do you need what are you looking for. Now in this case, notice how x is it is an angle, which is telling me that I'm going to have to use trig inverse. So nothing has changed. The only difference is I have to use trig inverse at the end. So the first thing I'm going to do is write my equation. So what trig function has both adjacent and hypotenuse in it? And that's going to be cosine. So cosine of my angle of reference, which was x, is going to equal to the adjacent side, or 34, over the hypotenuse, which is 55. Now because x is inside my function, I'm going to have to use trig inverse. So x is going to equal cosine inverse of 34 over 55. And that's what I'm going to put in the calculator. And so when I put that in the calculator, I get an answer of 51.8. And so here, x, or my angle measurement, would be 51.8 degrees. For question number 7, same thing. First thing is identify or label your triangle. I have an angle of reference, so across from my angle of reference is my opposite side. Across 90 is my hypotenuse, and next to it is my adjacent. I have information for the opposite side. I need information for the hypotenuse. And so the function, the trig function that has both opposite and hypotenuse in it is sine. So once again, I have sine of 23 is equal to the opposite side, which is 50, over the hypotenuse, which is x. And so because x is in the denominator down here, I'm going to take this whole thing, and all we're going to do is switch them. So here I would get x equals 50 over, now when you switch it, you have to make sure you bring the whole thing over, not just the 23, and not just the sign. You have to bring in both. And so that's the equation that we would put into the calculator. And if you're having trouble, make sure you put parentheses around here, and that'll help you out. And so when we put that in the calculator, we get an answer of 12.8. Moving on. So last one of these type of problems, number 8. So once again, first thing is label your triangle. So here's my angle of reference. Across from it is what we have the opposite side. Across 90 is my hypotenuse, and next to it is my adjacent. And so I have to figure out, I want information for the opposite side. I have information for the adjacent side. So the trig function that has both opposite and adjacent in it is tan. And so that's the trig function I'm going to use. So tan of my angle of reference, which is 37, is equal to x, which is the opposite side, over the adjacent side, 65. And once again, because x is in the numerator, I simply take the denominator and bring it to the front and multiply. And so that's the equation that's going to look like x equals 65 times 10 of 37. And so that's what I would put in the calculator. And when I put that in the calculator, I get an answer of 49.